So when I hear the word slope, sometimes I think of like skiing. If somebody says they're going to hit the slopes, that means they're skiing or snowboarding, right? And it's not totally unrelated to what we're doing in math class with slope. So what does the slope tell us about a line? The slope is something about a line. What does it tell us about a line? Does anybody remember? Let me ask a different question. If we're talking about skiing and we're talking about a slope, what are we talking about? What is a slope when you're skiing? It's a hill, right? Now, there's different kinds of hills that you can ski on. There's some steep ones and there's not so steep ones, right? So the difficulty of a slope when you're skiing is going to have to do with how steep the slope is, right? All right, so what slope actually tells us, it tells us a couple of things, but the main thing it tells us is how steep a line is. Just like when we're talking about skiing, it tells you kind of how steep the hill's going to be. All right, so the slope is going to tell us how steep a line is, but it's also going to tell us something else, and we'll talk about that in a second here. I'm going to use the skier here as an example to kind of demonstrate some things. So let's say that we have two slopes here, and we throw a skier at the top and we just let him go. Who's going to win? Who's going to get to the bottom first? What do you think, Mark?
The one on the left,
The,
no, the one on the right.
the one on the right, why?
Because it's steeper.
Yeah, so that slope is steeper, so that guy's going to get down to the bottom first. All right? Assuming that he doesn't like run into a tree or something like that, right? So the steeper slope is going to be is going to be where the skier is going to go faster. So one thing that we can kind of keep in mind when we're doing slope is the steeper it is, the faster somebody's going to go. That's going to be a bigger slope. All right, so this line right here has a bigger slope because the skier is going to go faster on it. How about this one? If we put a skier at the top of both of these, who's going to win that one? Aiden? Yeah, the guy on the right. Now, the only difference between this one and the last one, besides the fact that one's a little bit steeper, is what? They're going in. Let me go back to the last one real quick. This one, they're both going in the same direction, right? So they're both going to the right. And then on this one, they're going in different directions, right? Okay, so Aiden still recognized that the one on the right is going to be steeper, so it's going to have a bigger slope. All right, now how about this one? What do you guys think? Who's going to win here?
They're going to be at the same time.
They're actually going to finish at the same time. So does that mean that the slopes are the same?
Yeah.
All right, let me ask this. Forget about skiing right now. Let's say we're talking about math. And I tell you that the slope of this line is the same as the slope of this line. There's a little bit of a problem with that. What's the problem with that, saying that the slopes are the same? So the problem we have with saying the slopes are the same is that they're going in different directions. So even though they have the same steepness, the same slope, they're going in different directions. So the slope is going to tell us how steep it is. The bigger the slope is, the steeper the line is. But it's also going to tell us what direction it is. And Justin's exactly right. One of them is going to be positive, one of them is going to be negative. Does anybody know which one's which? Looking at these here, which one has a positive slope, which one has a negative slope? Mark?
The left one is the negative?
Yeah, the left one's negative and the right one's positive. The way you can tell is which direction do we read? Do we go from left to right or do we go from right to left? We read from left to right, right? We read in that direction. So as we go from left to right, if the line goes down, then it's a negative slope. If the line goes up, then it's a positive slope. Now, obviously for the skier, he's always going down, right? But since he has to go backwards, since he has to go to the left to go downhill, that those kind of cancel each other out. That makes this a positive slope. All right. So when we go from left to right, if you're going down, that's negative. If you go from left to right, you go up, that's positive. All right. And so the slope is going to tell us two things. It's going to tell us how steep the line is, and it's also going to tell which direction the line goes. So even when they have the same steepness, they might be going in different directions. So we have to take that into account. One would be positive, one would be negative. All right, so keeping that in mind and what we just talked about, does this line right here have a positive slope, a negative slope, or neither? It's possible that it doesn't have positive or negative slope. What do you guys think? It does have a positive slope because as we go from left to right, remember we're always going left to right. As we go from left to right, the line is going up. So this has a positive slope. All right, how about that one? As we go from left to right, is it going up or down? It's going down, right? So as we go from left to right, it's going down. So that has a negative slope. All right, how about that one? As we go from left to right, does it go up or down? Neither. It doesn't go up, nor does it go down. So it doesn't have a positive slope. It doesn't have a negative slope. There are actually two kinds of lines that are not positive or negative, and we'll talk about those in a second. All right, so we'll forget about that one for a second. How about that one? Positive or negative? That's negative because, again, as we go from left to right, it's going down. All right, and how about that one? That's another one that's neither. In fact, on this one, you can't go from left to right, can you? The only way you can go is up or down. So like on this one, you could start over here and go from left to right as you go down. Here, there's only one way to go, up or down. Two ways to go, I guess. You can't go left or right. So that's another one that's neither positive or negative. How about this one? As you go from left to right, which way are we going? Up or down? Up. So is it positive or negative? That's positive. All right, so there's two of them on here that are positive. The first one and that last one. Those are positive. There's two of them that are negative. This one here and this one here. And then these other two are neither. Now, what kind of line is this one right here? Starts with an H. Horizontal. What kind of line is this one right here? Vertical. So a horizontal line and a vertical line don't have a positive slope. They don't have a negative slope. They're going to be something else. They're not the same as each other. I think it's obvious that they're not the same because this one is really, really steep, right? How many of you would want to go skiing on this slope? I don't think so, right? And then this one isn't steep at all. In fact, if we put a skier on this one and we let him go, what would happen? He wouldn't go anywhere, right? They call that cross-country skiing. It's a little bit harder. All right, so what's the same about all four of these? They all have a negative slope, exactly. What's different about all four of them? What's different about all four of them?
Different slopes.
Yeah, different slopes. So they're different steepnesses, right? So this one right here is the steepest. This one over here is the least steep. So when we're talking about slope, they're all going to be negative, and this one's going to be the biggest negative number. This one's going to be the smallest negative number. And if we put some skiers on here and see what happens, this one would probably be me over here because I'm afraid of going too fast. Yep, I'd be on the bunny slopes. You can see that each of them have different steepnesses, and so the skiers are going to get down at different times. Remember, the faster the skier would go, the bigger the slope is. All right, same thing with this one. They're all the same in what regard? What's the same about them?
They're positive.
They're all positive slopes, but they're all different steepnesses, right? So I think it's obvious that this guy over here is going to go the fastest and this one's going to go the slowest if we just let him go. All right. Any questions about positive, negative slope and the steepnesses? The tricky ones kind of get to these right here. All right, so like I said earlier, this line right here, this horizontal line, it doesn't have a positive slope and it doesn't have a negative slope because as we go from left to right, it doesn't go up or down. All right. What would happen on this line if I put a skier there and let him go? Just drop him. What would happen? This guy right here. Nothing. All right, so that's what we said earlier. He's not going to go anywhere unless he starts kind of skating on his own, right? And you guys have seen cross-country skiers in the Olympics where they have to do that on flat ground, right? That's a lot of work, though. Okay, he's not allowed to do any work. How about this guy? What's going to happen here? He's going to fall off, right? So, you guys know Mr. Boyles? He's a math teacher here. When I was in high school, he was my math teacher. This is the way he taught these slopes. So since this guy's not going to go anywhere, the slope here is 0. All right, so the slope of a horizontal line is 0. Since this guy is going to fall off of the cliff, he becomes, anybody remember what it's called for a vertical line? Undefined.
If I were you guys, I would write this on the top right of your notes, just so that you.
Any horizontal line has what we call a zero slope. And, well, I'm getting a little ahead of myself here, but the letter we use for slope is M. We'll talk more about why we do that later. But just remember that it's M. So if it's a horizontal line, the slope equals 0. If it's a vertical line, it's undefined. And the way I like to remember that, the way I'll never forget it, is that if we put a skier on the side of the cliff here, he's going to fall off and become undefined. All right, so what we're going to do now is we're going to make this more mathematical. Instead of just saying it's a positive slope or a negative slope, or instead of just saying it's steep or not very steep, we're going to put some numbers to it. So what we're going to do, and you can look down at the examples at the bottom to see what we're getting into here. We're going to take a line and we're going to actually assign a slope to it. We're going to say that has a slope of 3, or that has a slope of -1. And by giving a number to it, we can compare one line to another and see which one's steeper. We can see which direction they're going. All right, so we're going to use a formula. It's not really a formula like other formulas you've seen where you just plug numbers into it. But we're going to use an idea of what we call run and what we call rise. Now, if you're going to go run, what direction are you going? Are you going vertically or are you going horizontally? If you're running. You're going horizontally, right? So if you're running, you're going to be running along the ground and you're just going to move in side to side. All right, so when we say run, we're talking about movement horizontally, which is along the x-axis. When we use the term rise, we're talking about going which way? Vertically. Okay, up usually, but if I say rise, but if I gave you like a negative rise, what direction do you think that would be? Down. So a negative rise would be the opposite of going up, which is going down. All right, so the slope formula is rise over run. So slope equals rise over run. Go ahead and write that down. And then I'm going to have you make a little note next to those. The rise is moving up or down. And the run, we said, is horizontal movement, so that's moving left or right. There's one other note I want you to put on here with that. Just like on the x-axis and the y-axis, we have a positive direction, we have a negative direction. So when we're moving up or down, which one do you think is going to be positive? Up. Just like on the y-axis, up is positive. So up is going to be positive, and down is going to be negative. On the horizontal direction, or in the horizontal direction, which way do you think is going to be positive? Okay, right is positive, and that means that left is negative, just like on the x-axis. All right, so when we're rising, it's just like moving along the y-axis. So up is positive, left is negative. I'm sorry, up is positive, down is negative. And then when we run, that's like moving along the x-axis, so right is positive, left is negative. All right, so after all that talk, let's put it to some work here. So what we're going to do is we're going to find the slope of this line right here. So we're going to give you a line on a graph, on a coordinate plane, and we're going to try to find the slope of that line. So we want to know, using the slope, how steep the line is, and we want to know what direction it's going, whether it's going in a positive direction or a negative direction. So the first thing we're going to do is we're going to pick 2 points on the line. Now, I picked 2 points on this line already. I want to show you. So when we're finding slope on a graph, slope on a coordinate plane, we want to pick points that are easy to work with. And the points that are going to be easy to work with are these points here, like this one, and there's a couple more here. Here's another one here that would have been a good choice. There's another one right here that would have been a good choice, and another one here that would have been a good choice. Those are all called lattice points. I'm going to use that term from time to time. If you want to try to remember it, it's not a bad idea to write it down. And a lattice point is where a vertical line and a horizontal line meet. All right, so what we're going to do is we're going to pick points that are at lattice points so it's easy to count. If we pick points that are in between, like this one here that I pointed out earlier, this would be a bad point because we don't know what the x-coordinate is for that point. Okay, you can see it's crossing a horizontal line, so we know the y-coordinate here is 3, but we don't know exactly where it is here between 0 and 1 on the x-axis. So we always want to pick points where the line is crossing through what we call a lattice point. All right, so I've chosen 2 lattice points here. And so to find the slope, what I need to do is I need to count the rise and I need to count the run. Remember, slope is rise over run, right? So I'm going to pick one of these 2 points to start at. It really doesn't matter which one you start at, except I'm always going to start at the one on the left. So if I always start at the one on the left, I'm always going to go from left to right. And if I'm going from left to right, is that positive or negative for my run? Which direction is positive for my run?
Up.
For my run?
Left.
To the right, right? So if I start on the left, then I'm always going to go in the positive direction going to the right. Okay? So I'm always going to start at the one on the left. It doesn't matter if you start at the other one, but you're going to have to deal with a negative run, and you might have to simplify the fraction. Actually, you will definitely have to simplify your fraction then. All right, so we're going to start at 1 point. Don't forget that our slope is rise over run. Remember I said m is going to be slope. All right, so what I want to do is I want to figure out, starting at this point right here, how far do I go up to get even with this point? That's going to be my rise. So starting here, how many squares do I go up to get even with this point? All right, so I agree with that. So our rise is going to be 4. Is that a positive 4 or negative 4? Positive. Why is it positive? Because we're going up, right? So the rise is going to be positive 4. And then once we go up and we're even with it horizontally, then we're going to go to the right. And how far do we run then, Scott? 2. All right, so our run is going to be 2. Is it positive or negative? Remember, when we start on the left, it's always going to be positive, right? Because we're always going to the right. So our run's going to be 2. All right, do you think this is a good way to leave my answer?
Do we have to simplify?
Yeah, we should definitely simplify that. So we don't ever want to leave a fraction unsimplified. Now, this is an example one, though, where we don't have to get rid of the denominator when the denominator is 1. Anytime we're dealing with slope, it's okay to leave it as a numerator and a denominator. So if we're going to simplify this, what goes into 4 that also goes into 2? 2. All right, so we can reduce by 2. And 4 divided by 2 is 2. And 2 divided by 2 is 1. This right here is an okay way to leave your answer. In the past, we've always said we want to get rid of the denominator when it's 1, right? Does anybody know why we might leave the 1 there? Why it's okay to leave it there? Scott? Since slope is rise over run, we like slope to be a fraction because then what that tells me is the rise is 2 and the run is 1. And actually, if you look at the graph here, if I start at any lattice point and I rise 2 and I run 1, I get to another lattice point that's on the line. I rise 2 and I run 1, I get to another one. I rise 2 and I run 1, I get to another one. So having a rise and a run is really useful. Are these the only 2 lattice points that it would have given us the slope for this line? No, remember, there were 3 other ones that I said we could have used. And it really doesn't matter which ones we use. We're always going to get the same answer. Since this is a line, the slope of the line is the same down here as it was up here. All right, so since the slope of the line is always the same, then our slope's always going to be the same answer no matter which lattice points we use. So you might use different lattice points than somebody around you, but you're still going to get the same answer in the end. So for example 2, let's do this one together, and then I'm going to have you do the other ones on your own. We need to pick 2 lattice points. So somebody help me out here. Zane, can you pick one for me? Okay, so Zane says where the line intersects at the top, the y-intercept right here? Yeah. All right, so that would be the point 0.03. We'll use that for one of them. And then this one right here? Okay. And then we'll use this one right here. All right, so I want everybody to use those 2 for this example. Okay, now using the rule that I said earlier, I always want to start on the left and go to the right. Do I want to start at this one here or this one here? Yeah, the one at the bottom, because this one's further to the left, so this is where I want to start. All right, so I'm going to start here at this point, and I'm going to start by finding my rise. We always do rise first because it's rise over run. So I'm going to do my rise, and how far up do I go there?
3.
So let's see, 1, 2, 3, 4, 5, 6. Do you guys agree with that? All right, is that a positive 6 or a negative 6? Positive 6, okay. And then once I do my rise, then I'm going to run. And how far do I run? 2. All right, so I get 6 over 2, and then I want to simplify. What goes into 6 that also goes into 2? 2. Okay, 6 divided by 2 is 3, and 2 divided by 2 is 1, so we get 3 over 1. We could have chosen different lattice points, and I want to show you really quick what happens here if we had chosen different lattice points. And I want you guys to decide whether this would be better or not. So I'm going to pick these two. And the biggest difference between the ones we chose earlier and these two is that there are no lattice points in between these. These are as close as they can get, right? So when I do that, if I do my rise, I get 3. And then I do my run and I get 1. So my slope is going to be 3 over 1. What do I not have to do here? I don't have to simplify, right? So when the numbers are bigger, we're going to have to simplify. So in order to make the numbers smaller, what we can do is pick lattice points that are closer together. All right, so if we pick lattice points that are as close together as possible, then you won't have to worry about simplifying in the end. All right, so I want you to go ahead and finish example 3 and example 4 on your own. We'll go through the answers in just a second here. So on example 3, I'm going to pick 2 lattice points. If you pick different ones, that's okay. You're going to get the same answer. You should at least. I am going to start at the one on the left. So I'm going to start over here. And my rise this time is going down. So what does that mean? My rise is going to be negative 2. And then my run from there is going to be to the right, so that's still positive. So we get a slope of negative 2/3. If you use this lattice point and this one, you would get negative 4 over 6, which also reduces to 2/3. For example 4, if we pick 2 lattice points next to each other, say this one and this one, then our rise is going to be up 1, so that's positive. And then our run is going to be 3, so it's going to be positive 1 over 3, and that's going to be your slope. Again, if you use different lattice points, you might get 2 over 6.